So we're looking at the definition of a limit. So we looked at it graphically just for a little bit last week until we had technical difficulties. So I'm just going to go through the definition again, and you should be seeing it on your screen on the top. So it says the definition of a limit. So given a function f, so we're given the equation or we're given the graph of f, the limit of f of x as x approaches c is a real number r if f of x can be made arbitrarily close to r by taking x sufficiently close to c, but not equal to c. So just going to ask you guys, I'm going to mute you. Okay. If the limit exists and is a real number, then the common notation is the limit as x approaches c if f of x equals r. Okay, that's a lot of mathematical terminology going on there. So let's actually see what that looks like. So I'm just going to draw a picture. So we might say, okay, here's, would help. Sorry, and draw a picture here. So we might have some graph of f of x. And let's say this is our x value of c. And so the limit of f of x as x approaches c is a real number, and it said r. So let's say this is where our graph is hitting when x is c. And so remember the limit was the y value as we get closer and closer to that x value. And you might not actually hit that y value of r, but you're getting closer and closer to that y value of r as x getting closer and closer to c. So as we choose some value here that's getting closer and closer to c, I go up to the graph. Notice that this is getting closer and closer to this r value here. I choose another value closer to c on the left of x equals c. Again, I'm getting a value that is getting closer and closer to this y value of r. Same idea if I'm coming in on the right-hand side of this c. If I come here on the right of c, if I come up here, hit the graph, this is pretty close to r. But if I get closer to c on the right-hand side of c, I'm hitting a number that is closer and closer to r. And so this is what that definition of limit is saying. We talked about last week that in order for a limit to exist, it has to be coming to the same y value as we approach both from the left-hand side and the right-hand side of that x value. And if we're not coming into that same y value, then that limit actually does not exist. We can look at one side of the limit. So just seeing what's happening on one side of that graph as we're looking at is x approaching c. So the definition of a one-sided limit, is the, again, y value of a function that approaches as you approach a given x value. From either the left or the right. I'm just going to do capital L for left and capital R for right side. So notice in this example 2, that graph, there's two pieces. There's a jump, and it looks like that jump is at x equals 3. And so that first statement says the limit of f as x is approaching 3 from the left side is -1. And this is how you would write it. So to denote, remember I said if we're telling us that the limit is coming on the left-hand side, you'll have this little negative that looks like an exponent to the x value that you're approaching. So underneath the limit, you have the x variable that you're looking at as you're approaching, the arrow, the number, and then if it's left or right, you'll either see a negative exponent-like thing or a positive exponent. And so let's look at it again. So when I'm looking at a limit, I first find the x value I'm approaching. So in this case, it's 3. this says that it's on the left-hand side. Oops, I didn't want to do that. Shoot, I'm sorry about that. It's on the left-hand side, so we're looking at the graph directly to the left of x equals 3. And so as we're coming down on the graph, following the graph, as x is getting closer and closer to 3, even though there's an open circle there, and we talked about that open circle there, meaning it's not defined there, that's not a point on the graph, it is getting closer and closer to this y value of -1 on the left. Okay. And if we're looking at it as it's approaching 3 on the right-hand side, so we have this plus exponent on the 3. So I would locate 3 on the graph, x equals 3. I would look to the piece that is directly to the right of x equals 3. And if we look at it and we follow it down as we get closer and closer to x equals 3, we're looking at the y value that you're hitting. And the y value that you're hitting or getting closer and closer to is a y value of 2. And so terminology or how we would read this is, and it's written out there, the limit of f as x approaches 3 from the right side is 2. So any questions about that?